Good morning, calculus class today. So I would like to talk about section 2.3, calculating limit using the limit laws. Okay, so there's so many formulas for this section here that you need to recognize. So let's go through all those formulas first. So given that the limit of f of x as x approaches a and limit of g of x as x approaches a exists, and c is a constant, so then the following properties exist. So the first one is called the sum. So once you combine that f of x and g of x, we can always take the limit separately. So the limit of f of x plus the limit of g of x. So the first one is called the sum. Well, because that it's all considered addition here. Okay, let me just put it into sum. And then the second one, obviously, is called the difference. So either you can condense them or you can separate them. And then the other one, the third one, this one is called the coefficient. So the value of c, it's called the coefficient. So the coefficient property of limit. And now let's see what else that we have. And then for the fourth one, it's called a product. So instead of multiplying the function first, we can find the limit of f of x and g of x. And then whatever the result that we have, we can just multiply those numbers. So it's a product. And then the next one, it's a quotient. So one thing that you need to watch out for the quotient, the denominator cannot be 0 because that the whole thing would be undefined. So that means for the limit of g of x as x approaches a does not equal 0. And then number 6. So number 6 is called the n degree or the power. So you can say that n degree. So instead of taking that the function with the power, so we can just take the functions, the limit of the function first. And then whatever the result that we have, we just raise up to the nth power. And keep that in mind where n it's a positive integer. Okay, and it's a positive integer. If that's a negative integer, that means we have to do something else about it. And then for number 7, so number 7 is called a constant. So the constant property. And then for number 8, it's called the variable, the linear variable. Or linear function. And then for number 9, this one is called a polynomial. So anytime they want to take the limit x to the power of n as x approaches a, so we just plug in that a here. So this one is called a polynomial. And again, the condition for this one where n is a positive integer. So now let's see what else that we have. So the next one is called the nth root. So where n it's a positive integer, so this one is called the radical. So radical. And then 11, it's called the nth root of f of x. So it's a radical of a function. So instead of taking that the limit of the radicals of a function, you can take the limit of the function first, and then take that to the nth root. And then number 12 is called the squeeze or the sandwich theorem. So let's say that we do have a functions, g of x. So g of x, it's somewhere right between f of x and h of x. So this one, let's say that it's g of x right here. And then we do have a functions, f of x. And then for h of x, so that's going to be like this. So one is g of x, the other one is what? H of x. This one's supposed to be h of x because that's greater than. And the other one down here, this one's supposed to be f of x because that's less than. Okay, so once you set up the function like this, so in order to find the limit at that positions, so we just want to find out the limit of the upper bound and the lower bound. So the limit of the upper bound and the lower bound. So once you squeeze this together, so once you compress this, so that means eventually the limit at this position is going to be considered the point where they all intersect. So let's say that the limit of f of x as x approaches a is the same as the limit of f of x of h of x. Well, if they're both considered L, so that means the limit of g of x, because g of x is right between, so the limit of g of x also exists. So that's also considered L. Okay, so this one is called a squeeze or the sandwich theorem. Okay, so now let's see. Let's try to use some property, and then we try to find the limit from the property. So the first one here, so we do have polynomial, so we can use the polynomial property. And also we do have subtraction, addition. So anytime that you see the limit, the polynomial functions, so that means there's no restriction. Restriction, that means the domain. So you see that the domain for the polynomial, it's always considered from negative infinity to infinity. So that means we can just plug in a number. So 3 times negative 2 quantity to the power of 4 minus negative 2 plus 1. So negative 2 quantity to the power of 4, then that would be considered 16. 16 times 3, so which is 48. And then plus 2 plus 1, so eventually the result is what? 51. And now what about this one here? Radical, so cube root, cubic functions. So again, there's no restriction for the domain. So basically we can just plug in that 8 here. So we do have 1 plus cube root of 8. And then times the quantity of 2 minus 8 to the power of 3. So 1 plus cube root of 8, that's 2. And then 2 minus 8 to the power of 3, so 64 times 8. Let's see what that is. So 4 times 8, 32. 6 times 8, 48 plus 3, 512. Okay, so that one is 512. And then try to evaluate it. So what we got here, so it's 3 times the quantity of negative 510. And then multiply this by using the product property. So 3 times negative 510, so we do have negative 1,015, negative 1,530. Okay, so then that'll be the limit for this product of two cube root and cubic function. And now, what about the one-sided limit? So again, for the one-sided limit, if you don't see any restriction for the rational, for the radical functions, so that means you can plug in a number. So basically this one you can just plug in that 16 minus 4 squared. For those you might be wondering, well, should we put in that 3.9999999? Because that is something, well, it's x is getting closer to 4 from the left hand side. Well, once you put in 3.999, so try to approximate it, what is that about? That's exactly at 4. Again, if there's no restriction, just plug in the number directly. So 16 minus 16, so that's 0, square root of 0, so then that'll be 0. And now, what about for d? So what happens if I just plug in the number directly? We do know that the expression here is considered rational. And remember back to Algebra 2 and Pre-Cal. If that's a rational expression, the denominator cannot be 0. So try to find a restriction for the denominator, x cannot be 2. So try to plug in 2 here, so the whole thing will be considered undefined. So here's what we need to do first. So anytime they see the restrictions, you always want to come up with a way to cancel the restriction. The way to get rid of the restrictions, you can always factor it. So the top part right here, once you factor it, so we do have x minus 2 times x minus 2. It's a perfect square trinomial. Denominator, so same thing, x minus 2. So we can just cross those common factors. And then what we got left here, we do have x minus 2. So limit of x minus 2 as x goes to 2. And now there's no more restrictions, so now we can plug in the number. So eventually the limit is going to be 4. Okay, so, actually 0, excuse me. It's not plus. Sorry about that, going too fast. So this one's supposed to be 0. Okay, so now let's see what else that we have for the rest of this. Now, as you can see that the examples, they're getting a little bit more difficult, more sophisticated. Evaluate the limit if exists. So again, first thing that you want to do, so check the restrictions. So let's say that you plug in negative 3, so it looks like this one is going to be 0. Again, denominator, you cannot set the denominator equals 0, because that would be undefined. So what we have to do first, once again, we want to factor it. So t minus 3, t plus 3, the difference of 2 squared. Denominator, so this one is like 2t and t. And we need to end up with 7 here in the middle, so that's why we need to put in 3 here and 1 here. Because that's 6t plus 1t, then that'd be 7t. Again, things that they share in common, so t plus 3, so we cancel them out. And now there's no more restrictions, so that means we can just plug in the number. So negative 3 minus 3, so that would be negative 6. And then 2 times negative 3, negative 6 plus 1. So that would be negative 5. So 6 over 5 of the limit. And then for this one here, similar. So what we need to do first, try to factor it. X plus 2, nothing is factorable, just leave it. But this one, what is this? It's a sum of 2 cubed. So we do have x plus 2, and then times the quantity of x squared, minus 2x plus 4. Again, cross out the common pair, so we do have limit x goes to negative 2 of the quantity, 1 over x squared minus 2x plus 4. So there's no more restriction for the domain. So basically we can just plug in a number. So plugging a number, we do have 1 over negative 2 quantity squared minus 2 times negative 2 plus 4. So evaluate it. So let's see what that is. Would that be 1 over 8? Let's see. So it's 1 over 4 plus 4 plus 4. Well, it's actually 1 over 12 for the limit. And now, what about this one right here? Again, if you just plug in 0 for b, everything turns out to be undefined. Same thing happened here for d. So now for c, what you need to do first, you want to expand it, especially the numerator, expand it. We can use the Pascal triangle, or we can use that the binomial expansion. So by the time that you expand it, so the top part turns out to be 8 times 8 plus 2 squared times b times 3. Okay, let me just rewrite it. That looks kind of ugly. Give me 1 sec right here. So a, 2 to the power of 3, and then plus 3 times 2 squared times b, and then plus 3 times 2 to the first power times b squared. So what I'm doing here, I'm kind of using the Pascal triangle. As you can see that it's 1, 3, 3 for the coefficient, and then plus b to the power of 3, and then minus 8, because that negative 8, you want to carry that all the way through. And now it's all over b, but don't forget to bring down the limit, because we're taking the limit for this whole expression. And as you can see that 8 minus 8, so that's going to be 0. And now what's left? So we do have 2 squared times 3, which is 12b. 2 to the first power times 3, so that would be 6b squared plus b cubed over b. Another thing that you can do here, you can divide each term by b. Or we can just take out the greatest common factor b on the top, and then we can just reduce it. So what we got here is the limit. B goes to 0, so we do have 12 plus 6b plus b squared. And then plug in 0 for everything. So we do have the limit, which is what? 12. Because once you multiply by 0 for the rest of those terms, so everything else turns out to be 0. 0, 0, so what's left? Just 12. Okay, so now let's see what else that we have for this. So for D, that one looks a little bit complicated. And for those you might be wondering, what can we do for D? Can we factor anything out? Can we reduce something out? Can we just pull out the greatest common factor? Well, another strategy for simplifying the expressions, if you guys do remember, if you see the conjugate of the radical, guess what we can do? We can always rationalize it. So back to Algebra 2 or pre-cal. If you see the conjugate, if you see that the pattern is like root A plus root B, that means the conjugate would be considered root A minus root B. So basically this one, just using that the conjugate theorem, you can just multiply the conjugate of the numerator, top and the bottom. So the conjugate of that square root of 3 plus x minus root 3, so that would be considered square root of 3 plus x plus root 3. So again, so basically the radicand, they're exactly the same. The only thing that you need to change is the negative and the positive. So if that's negative, so you want to convert that to its positive. So make sure that you multiply this one top and the bottom. Anytime that you want to rationalize something, so that means you want to multiply the exact same conjugate top and the bottom. So let me change the color back to purple. Oops. Okay, so multiply it straight across. So this one here, we do have limit. X goes to 0, so we do have 3 plus x minus, well, root 3 times root 3, then that's just 3. And you may notice that we do have x times. Now what about the conjugate down here? So this one, I just want you to leave it with that, the original form. So square root of 3 plus x, and then plus root 3, just give it that way. Now one thing that we noticed, 3 minus 3 got canceled, so what's left on the top? X. So you might be wondering, what can you do with the x? So we do have 1x on the top, 1x down the bottom. So basically we can just cross out the x's. So what's left eventually, it just limit x goes to 0 of the quantity, 1 over the conjugate. So square root of 3 plus x plus root 3. And you might be wondering, there's no more restriction. Yeah, there's no more restrictions. Guess what we can do? Plug in a number. So we do have 1 over root 3 plus 0, then that'll be root 3. Plus root 3 again. So we do have 1 over 2 root 3. And you might be wondering, can I rationalize it? Yes, multiply by root 3 top and the bottom. So eventually, so rationalize it. So let me put it right up here. So 1 over 2 root 3 multiplied by radicals of 3 top and the bottom. So you end up with root 3 over 2 times 3, which is 6. And that would be the final limit. So try to find out some of the problem like this for the practice. So most likely, you'll see something like this on the test, okay? Radical, conjugate, rationalizing, cubic functions, expand it with the Pascal triangle, or you can FOIL. Okay, so now let's see what else that we have. So prove the following limit by using the squeeze theorem, okay? So now this one, you might be wondering, what can we do in order to show that the limit is 0? So again, prove something that you guys don't want to deal with. So back to the last math class, the one that you're doing proof. So this one might be considered going back to either trigonometry, the trig identity proof, or back to geometry, the 2-column proof. So now what we can do here, we can start it off with cosine, the trig function first. And one thing that we do notice for cosine, it's an upside down bell curve. It doesn't matter what kind of cosine function that is. If the coefficient is considered 1, so that means the range is always being bounded from -1 to 1. So for this one here, we can just stay with the range from -1 to 1. Okay, so just stay off with the range. And now, what else do we need to put in for the rest of this? So the rest of this, we need to put in that x to the power of 4. Now, one thing that we notice, the limit as x goes to x to the power of 4. So this one, there's no restrictions, so we can plug in 0. So 0 to the power of 4, which is 0. So basically, we just put in that x to the power of 4 for the limit. And then guess what we have to do for the left bound and the right bound? So we just want to plug in 0 here. Plug in 0 here. Well, because that, it's always 0. It doesn't matter which way that's being bounded. So -1 times 0, that's 0. And then what else? 1 times 0, the right bound, it's also 0. Normally people call this one as the lower bound, upper bound. Doesn't matter. Either way, it's fine. Or you can say that the left bound, right bound. And then eventually, what's the limit for that x to the power of 4 cosine of 2 over x? That's right. It's all 0. Because the limit of the upper bound is the same as the limit of the lower bound. So therefore, the limit of the whole quantity is 0. So that's the way to show the proof. So always start it off with the cosine curve, the range, and then you want to put in the rest of those elements. And now, what about for this type of function here? So it looks like this one is considered a product of radical, exponential, and then with the inner exponential function, we do have a trig function. And also, for the inner function of the trig function, we do have a rational. So this one looks like it's very complicated. But again, no need to be freaking out. So the first thing that you want to do, so start it off with the trig power. So sine of pi over x. So again, for the sine curve, it's always considered a roller coaster back to the parent graph. It's always bounded from -1 to 1. So this one, we can just set it up -1 to 1 for the range. And now you want to put in the power, the base. So base e all three sides. So e to the -1 power, e to the power of sine of pi over x, and e to the first power. Another thing that you want to do is that the one-sided limit with that square root of x. So square root of x. You try to sketch the graph so it's like a half sideways parabola, started off at 0, and there's no restriction for that square root of x if x is greater than or equals 0. So x goes to 0 from the right hand side, so that means we plug in 0. So plug in 0 for this, so we do have e to the negative 1 power times 0, and then square root of x. Again, that's just expression, so put it in e to the power of sine of power x. And then for the upper bound, also multiply that by 0, so e times 0. And you may be noticing that this one is all 0, 0. This one simply bring it down, so I'll put in ditto. So again, the limit from the left bound and the right bound, they're all considered 0, or the limit from the upper bound and the lower bound, they're always considered 0. So therefore, the limit of this whole function is what? 0. Okay, so I'll just bring down ditto, which is the expression. Okay, so now let's see what else that we have for this. Okay, so now the rest of this is getting a little bit more complicated. Okay, so now we'll take a look at that. Integer function, so this one we have to use a graphing calculator. And that's another video I'm going to show you later. Okay, so I'll put it into the second half of the lecture. So let's just stop here so far. Again, the way to find the limit by using the properties. Okay, so back to the property here once again. The sum, the difference, the coefficient. And then the product, the quotient. And this one is the nth degree, constant, linear variable. And then the polynomial. This one you can say that's a linear function. That sounds a little bit weird. That's a linear variable. Because at the highest power, it's 1. That's why it's linear. And let's see what else that we have. Nth root, the radical. And the radical of a function. And then the squeeze theorem. So those are the very important formula or the property that you need to recognize. Well, not just recognizing it, make sure that you know how to apply the property. So for the limit, finding the limit. Okay, so that's it. So for example 4 and 5, so I'm going to be making another video for this. Okay, so I'll see you later. Take care.